Kingston, Ontario, Canada, at the Kingston Mill. We're going to first start off showing you some historical sites, and at the same time showing you some incredible little hidden secrets. Kingston Mill, and you can see the water gets held back over here, the Rideau, and it empties out at the other locks into the Great Lakes. We are at the Kingston Mill, Lock 46, located at Colonel By Lake. I'm going to go down and verify the water level with my kayak. Since its construction in 1832, the water level have been maintained at 88.65 meters above sea level. The water flows down to Lake Ontario, and Lake Ontario's water level are approximately 74 meters above sea level. I took a picture of the water measurement showing the water levels at 88.63 meters above sea level. I then proceeded to Lock 45 at Lower Burrs to verify the water levels at the opposite end of this waterway. And it's 3:20 and we're at the Lower Burr locks. And as you can see across, there's our water level, and it looks like it's 88.7, but you can see there's some water being pushed out, so I could see an inch increasing. But let's go down and have a closer look. The indicator right now, and as you can see, the water's gone down a bit since the water rush has stopped coming out. And we're looking right now at 88.67. I'll zoom in. As you can see, that's our water level here. See, on the other side of the locks you have a dam, and they've got it open, so the water level is a bit high, so they're just exiting the water, which on the other hand would show you that the locks are just a bit higher here because we got more water coming in and the water's leaving up in Kingston. Anyway, we got to do some calculations now and see what's the earth curvature to this place. I'm sure you'll be surprised. On RideauInfo.com, you'll find all the information regarding the locks. From Kingston Mill to Lower Burrs, there's a distance of 15.7 kilometers or 9.8 miles. On the same website, you will also find on the RideauInfo.com the profile of the Rideau Canal waterway. What we're going to be looking at is the Cataraqui River, and the distance again can be confirmed at 15.9 kilometers or 9.8 miles. And the Kingston Mill, we had the water levels at 88.63 and at Lower Burrs at 88.67. And again, their water level is indicated at 88.65 meters above sea level. Now, when we go into the next phase is the Earth Curve Calculator. This is where we're going to find how much curvature is missing. And when we do put the information of 9.8 miles into the calculator and press calculate, we get 64.05 feet of missing curvature. This means that the water from one lock to another, if we stood at one, would have to be 64 feet down from the other. Well, horizontal is pretty much horizontal, and this is measurable. And water lays flat and horizontal. As if we were to put it on the Earth curvature, the water would have to drop and away from us. Well, the profile of the Rideau indicates that we have 45 locks, all level and horizontal. And we have 200 kilometers of waterway that would indicate 3.13 kilometers of missing curvature. And by the way, the map, it was made in 1829. The numbers haven't changed since then. The Rideau waterway empties out in Kingston, Ontario, which is in Lake Ontario. And I've got a profile of St. Lawrence Seaway and the Great Lakes. And you can see the water below all rests level and horizontal. Now, if you took the distance from the Lake Superior to Bournois Dam, there's a distance of 2,212 miles. And if you put that in the Earth Curve Calculator, we're looking at 602 miles of missing curvature, or for my Canadian friends, 969 kilometers of missing curvature. Now we know level is horizontal. And if you have horizontal lines, you have vertical lines perpendicular. All these lines are parallel to each other. On a sphere, all these vertical lines cannot be parallel, as the sphere with the vertical lines on it. Here I took a section of the Rideau Canal. I started from the upper Rideau Lake down to Lake Ontario. What it is, I drew at the water level, level horizontal line with perpendicular vertical. All lines are parallel to each other. Can be shown with the right angles, and this is what we see. The same can be said about the Great Lake water system. Again, from the water, I drew a level horizontal line with perpendicular verticals, all parallel to each other. And again, you can see we all have right angles, and this again is what we see and what we can reproduce. I entered vertical and horizontal. I wanted to check the definition of these two when it applies to a sphere, and I wanted to make sure that I don't make a mistake. And what we found is vertical and two separate points are not parallel. The same holds for the associated horizontal plane. Well, I replaced those two lines with a sphere with lots of verticals, and this is in contradiction to what I'm showing on the two water system, or any water system for that. In real life, we observe level horizontal lines with perpendicular verticals. This is testable and repeatable. A point I cannot stress enough is water always finds its level. Either in the ocean, Great Lakes, pond, tubs, water bottle. When it comes to what you see, remember, nature does not lie. Man does. Nature shows us its beauty, its simplicity. It's quite easy. Keep asking questions and don't fall for the sphere fallacy. Anyway, cheers, and I hope you enjoyed the video. And like everything else, it is what it is. It's flat.